Hey.
Welcome to Module 2. So we're back to trying to identify questions to be answered about possible relationships in data. Only we're going to focus this module on two variable data. Mr. Bobby is sidetracked today. So we're going to try to liven him up.
I just had a busy day and I got new puppies over the weekend. So I've got, it's not me who's sidetracked. My dogs were sidetracking me.
Oh, okay. All right. All right. So remember that one way we might look at bivariate data, if the data is categorical, are these stacked bar graphs. So you can see in this graph that we're looking at course ratings and some social science majors like anthropology, sociology, economy, and students responded, assuming students responding, very good, good, neutral, bad, very bad. Okay, so this is one way, and you have seen it a lot now, where you might introduce bivariate data, or in this case, multivariate data, but what would we look for?
You may not be familiar with this, but when you're in college, every time you take a college class, you get to fill out an evaluation for every college class you take. So this allows the university to compare professors and different courses. So you can see here, if I could see that the psychology class had a lot of good ratings compared to, say, the economy class. So that may be there's a really good professor, or it just might be a more interesting class.
Yeah. So when we're looking at graphs, kind of the things you want to focus on are what's very, very different, or what's really similar, right? So if we look at anthropology and economy, those to me are fairly similar rated.
Yeah, I guess so. But and you might also look at, I would look at how people, when you're asked a survey, people don't always say bad things. So something must have been going on in this other class for there to be a bunch of bads.
Yeah, the very bads. Not a lot of people mark very bad.
Yeah, people tend to be too nice in surveys. I'm afraid they're going to find out that I said it. So whatever this other class is, I probably don't want to take that. And I'd be a little apprehensive of psychology, because some people actually have the guts to put bad.
Yeah.
That don't make me too happy.
Something wrong. Something's wrong. Yeah. Here's another. I'm actually going to skip through this. I don't know. Stacked bar graphs. I think you think kids got him?
I think so, especially when they look almost exactly the same. In that case, you can tell that the food production didn't change much in that time frame.
Not a lot of association year to year to year to year.
No, I think, yeah.
You might also be trying to compare and using a dot plot. So kind of a quick rundown here is production downtime during the day shift versus the night shift. Downtime is only 28 minutes in the night shift, but during the day shift, you got 37 minutes of average downtime.
Looks like there's people during the day are awake enough to be gabbing.
Yeah. So again, interesting things to look at, what's different. I do think it's interesting here that the shape of them are very, very similar to each other. So production looks similar, just how many minutes of downtime you're taking kind of.
And when you do your custom BS for a graph like this, you can say that they're approximately normal, or, you might say the night shift is skewed to the right, but they're not going to really freak out if you say approximately normal.
Right. How about this one? So similar to the starburst activity or lab we looked at, we've got a scatter plot here. And this one jumps us from categorical data to quantitative. And you can see we've got quantitative data or years, median Arkansas income. And we want to start asking questions if both variables are quantitative, what kind of questions might I want to answer here? So why might I collect the median Arkansas income from 2000 to 2018. There are a lot of questions that I might want to start looking at here.
Sorry, I don't know what's worse. Dogs playing in the house or dogs barking in the backyard? What's worse?
So one of the things that we do want to make sure we look for when we're looking at a scatter plot is there a pattern? What do you think? Pattern?
I do kind of think that there's maybe a little bit of a trend that the income is going up over time, but it does seem like it's kind of erratic and there's some dips here.
Yeah.
I'd like to know what's going on in 2008 to 2012.
Yeah.
Now, the kids may not, y'all who are students, y'all may not remember this too well because you might have been a kiddo, but we didn't do too good at those times. There were some bad economy things happening here.
Yeah.
And so what happened is like we kind of maybe went back down a little bit because the economy kind of tanked.
Yeah. We've got this decline and then this incline, right?
And it would be interesting to see where we are if we get more recent data. We don't have that data because it takes a while to compile it, but I suspect that it's maybe going to go back down in 2020.
It might, yeah. So I do see, I agree with you. The pattern might be decreasing, but then all of a sudden increasing. So unlike the, maybe the other stuff you've seen, something kind of strange going on here. This dip specifically, we'll probably circle back to this graph at some point.
We will see, this kind of thing a lot.
Yeah. You want to read for us, Mr. Bobby?
Sure, and as long as my dogs don't freak out again. Okay, there's always variation in data, whether the data measures something as simple as daily temperature or as complex as the successful surgical procedure. So like today it was hot and then it started raining. So I'm sure the temperature plummeted. So things happen that change it, okay? That's what that's saying. There's always changes that are perhaps unpredictable, but sometimes they are predictable. Anyway, variation, according to Walter Schuhart, I guess that's how you say it, can be viewed in two ways, either as an indication that something has changed or a random variation that does not mean a change has occurred. So understanding that nature of the variation is what we're after. That's the paramount in decision-making and improvement efforts.
Yeah, yeah. So, people will argue with global warming, oh, it just happens. It just happens. But what we look for is is there a trend? Right? Does it keep happening in that same sort of pattern? And that's what we're going to start looking at is that random variation and what does that random variation mean for us? Okay, so one of the things we have to hammer into our brains is that patterns and association could be random or not random, but you can't assume. You cannot say it has a pattern. That means I can draw an immediate conclusion. Cannot do that.
And unfortunately, a lot of what you see and hear and read or whatever, either on the news or on the internet, they forget this, okay?
Yes.
As a statistician, just because we get two data that seems to be related doesn't mean that one thing is directly the cause of another.
Right. So that's the crux of what we're looking at here, what he just said. Things will be related. They'll be related. But just because they're related doesn't mean one of those things caused the other. And that is correlation and causation. Oftentimes in statistics, these words are used interchangeably, but they absolutely should not be. So we want to make sure that we understand that we find a correlation, but we don't assume that causation piece. All right, so bivariate data, we've talked about this before. When we look at bivariate correlation, we're going to use a statistical technique that determines the existence of a relationship between two variables.
We'll be able to show a mathematical connection.
Right.
It doesn't mean the two are one's causing the other. It may be some other reason, but we'll talk more about that.
So then we say, okay, well, then causation is the key that unlocks the door of the experiment. The explanation behind the mystery. These are correlated with each other. Here's the cause over here. Okay, so correlation is like think about it like a class of keys, and then the causation is the specific key you're looking for. I think there's a ghost.
Well, it could be. Hey, I mean, you don't have. At least you don't have dogs freaking out on you, right?
True. So let's look at this
now. So I think we're okay.
Okay.
Yes, the new dog is named Hamilton.
Hamilton. I hope that you guys know what that's from. So here's what we have here is a 5 years of monthly data on patient beds. And if we didn't have that line in the middle telling us, you can see that the data is kind of spread out. Is it spread out on this side? I forget that the camera slipped. Spread out, and then all of a sudden, it kind of clumps together, right? So we know there's probably a correlation between the time and the number of patient beds. And we see that it's decreasing, yep.
Like those are all kind of lumped together or not really doing a whole lot of anything, just kind of fluctuating. But then if I look here, if I circle those, there's kind of seems to be like a downward trend at that point. So that's what I'm seeing. Sorry.
Right. No, perfect. Yeah. So the causation piece is that the physicians opened up an emergency clinic and it opened up beds, patient beds in the actual hospital. And so that's your causation piece.
It's interesting that you brought this up because we were talking. We're doing both these classes together, and I was doing something for college algebra about COVID-19, and I saw perfect data until about mid-March. What happened in mid-March 2020?
I wonder.
Yeah, we all know what happened in mid-March. The graph was doing one thing, and then in mid-March it started doing something different.
Yeah.
So that's and it wasn't that days in COVID-19 affected each other. We did something to change it.
Yeah.
It's beautiful to see that and live through it. Well, maybe not in this case.
Okay, so here's a graph. We've got the sales of some sunglasses correlated with the sales of some ice cream. I see a line.
This is kind of oversimplifying it, but I kind of like to circle the majority of the data, not draw a line. I know that you maybe were tempted to connect the dots, but you can't connect the dots. But I kind of think of it as like the blob. If it were a blob of data, does the blob seem to be going in a certain direction? And this blob seems to be going up and to the right.
It does, up and to the right, yeah. And they all seem to kind of fit a nice pattern together. Any pattern. It doesn't have to be a linear pattern, although that's what we're going to focus on. I could have data that
we're doing like this. My blob could be like a banana or something. You know?
A banana. So we're always looking for like, can we see a pattern? Because if we can see a pattern, then that tells us that there's some kind of correlation.
No. Oh yeah, there's some correlation. There's not. Yeah.
But that doesn't mean, for example, here that because I buy sunglasses, I'm also going to buy ice cream, right? That's the that's that piece that you have to be careful of, right? That causation piece is, do my sunglasses affect my ice cream? Like, oh, I can't eat ice cream unless I'm wearing sunglasses, so I better go buy some sunglasses.
So stop and think about it. The question she just asked, can I go to my refrigerator and get some ice cream and eat it without breaking out my sunglasses? Yeah, I could do that.
Yeah, I mean, I can. I don't know about you.
And I could wear sunglasses without eating ice cream.
That's true. Although you could also eat ice cream and wear sunglasses.
And wear sunglasses. I could do that. But I don't have to do one to do the other.
Right.
Okay.
So it turns out that another thing is correlated here. Turns out that ice cream sales and homicides in New York, and I don't have a graph for you on this one, but homicides and ice cream are also correlated. So if you graph these together, you're going to see a pattern. there is a correlation between ice cream sales and homicides in New York. Mr. Bobby just left us. Oh wow, he got a butcher knife and some ice cream.
I got unicorn swirl, which is delicious, by the way. And like if I want, am I ready now?
The fact that Mr. Bobby's ice cream is a unicorn swirl. I mean, I just can't.
I mean, okay, so these two.
So do you think the homicides, like you can't kill somebody without eating ice cream, is that the causation here? Or do you think like eating ice cream makes you want to kill people?
I hope not, because I really enjoy my unicorn ice cream.
So
I'd like to keep my wife around.
Yeah. So this is the, I like to keep my wife around. This is that correlation causation piece, right? Just because these two things are correlated doesn't mean that one caused the other. So stop and think to yourself for a second. What do you think could be a cause of these two things? Like what does eating ice cream or potentially eating ice cream and potential killings in New York City have in common? Well, turns out it's the weather.
When it's cold outside, people don't get out as much or stay locked,
Right. You got a lot of, in the summertime, you got a lot of people kind of meandering around New York. That's a lot more opportunity for not great people. It's also an opportunity to go eat ice cream. So, I mean, you could go either way with this, right? You could go kill people or eat ice cream. I'm not telling you to go kill people. Please don't tell your mom that today.
Or you can wear sunglasses, okay?
Yes. And wear your sunglasses, of course. Yeah, that's also the weather part, right? That's the correlation and the causation piece. So there's going to be a book that we slowly read, and we're going to go ahead and start it. It is called How to Lie with Statistics. It was written in the 50s. It's
old, but
still relevant, shockingly relevant. Okay, there'll be a link to both the book, it's a PDF version, and an assignment that goes with that first chapter linked in Classroom. It's also linked on your student checklist, okay? I will see you for the next video. Oh, can we talk about these falls in Venezuela? They're beautiful.
Yeah.
I mean.
What happened to the dogs?
We're on to places I would like to see in real life.
Oh, okay. I'm sorry.
Bye, guys.
Bye, guys.